Okay. Okay, so even if you were to have two similar products, okay, for example, we have okay, so we have two cans of sardines, okay, from two different manufacturers. So the ingredients and the composition of, even though both are cans of sardines, okay, but the ingredients, the compositions will differ. Okay, so when this differs, okay, so too will the factors that will affect them. Okay, that will threaten that particular food system. Okay, so what we show, these are just some generalizations, something which is general in nature, but in specific it will differ. So it depends on the food system. So that is why the approach to food preservation, okay, basically first and foremost is for you to understand and know your products. Okay, understand and know your products, what its composition, how is it going to be used, okay, for how long that you want it to be stable, okay, and what are the modes of transportation, how are the consumers going to interact with your product. So know your products, and then based on those, okay, you need to determine what are the threat factors from the chemical aspect, from the physical aspect, and also from the biological aspects. Okay, so based on that, then we try to apprehend, okay, or restrict the effect of those threat factors, and that will be the approach of for preservation of that particular product. Okay, so there are no standards. So it doesn't mean that, okay, just because it is biscuits, so you have a standard approach of preserving biscuits. Okay, there's no standard. So you have to understand and know your products. Okay, and we have discussed about the effect of low temperature, because we are talking about food preservation using low temperature. So actually, how does low temperature affects the threat factors? So that is important for us to understand, so that we know when we apply low temperature, okay, so what is it going to do to our food product? Okay, okay,
Doctor,
yeah,
sorry, may I ask, what is the symbol for resin red?
I'm sorry,
What is the symbol for resin red?
for resurrect
Yes, yes, resin red.
symbol, a
Yeah.
symbol. Sorry, I can't understand you. The
No,
you
I
want
mean I mean the symbol of resin red in calculation.
uh the symbol for resurrect. What is resurrect? Is it possible for you to type it in the chat?
Resin red.
I think he mean the reaction rate.
Reaction rate. Is it?
Yes,
Is it reaction
yes.
rate. Okay. The symbol. It doesn't have a symbol.
Okay.
It doesn't have a symbol. Reaction rate, usually the unit is usually based on time. So when you have like for example the reaction rate for browning, then it depends on what parameter that you are using. Okay, for example, if you are using a color meter, then the unit will be L asterisk. So it is L asterisk per time. So that will be the rate. When we talk about rate, then it will always be in reference to a change in time. Will that be okay, Chung?
Okay.
Okay, okay, thank you. Okay, so let's continue. Okay, so and we also have looked into the effects on enzyme reaction rates, okay, microbial growth rates, okay, and we have also started uh, on the history a little bit, touched a little bit on the history of refrigeration, basically chilling, freezing. And then we have started our discussion on chilling. Okay, so basically when we talk about low temperature food preservation, it is about chilling, and also another approach is freezing. Okay, the difference is basically to what extent do we lower the temperature. If we were to lower the temperature but still maintaining it above the freezing point of water, then it is called chilling. Okay, in Malay it is called penyejukan. Okay, but if we were to reduce further the temperature, go beyond the freezing point of water, then we call it as freezing. In Malay it is in Bahasa Melayu it is penyejuk bekuan. It is based on sejuk beku, so it is penyejuk bekuan. Okay, so we have penyejukan and also penyejuk bekuan, chilling and freezing. Okay. Okay, and we have discussed about meat. Okay, I think we have completed it. We have discussed about the degradation, the threat factors for meats, a little bit on the biochemistry of meat spoilage. All of this we will further discuss in food chemistry. Okay, we won't go into the details into really deep, because this course is for food preservation. Okay, so and we have discussed about the meat preservation by chilling. Okay. Okay, so the next one is next product is about poultry. Okay, so poultry, it is also meat based, okay, or protein based to be exact. Okay, so let's look at the post-mortem chemistry first. Okay, it is quite similar to meat because it is also protein based. So when post-mortem, meaning that after death, okay, so glycolysis, okay, will occur. Okay, glycolysis will occur where glycogen will be converted into lactic acid. Okay. Okay, into lactic acid. Okay, and then what happened is protein degradation, because after death, then there will be no process for homeostasis. Okay, the preservation of the physiology condition of the animal. Okay, so loss of biological activity, loss of solubility, the protein solubility. Okay, loss of water binding ability. Because protein, it is not only from a nutritional point of view has its benefits, but also when we talk about food products, okay, protein also has its functional properties. Okay, for example, like solubility. Okay, when protein is partially soluble in water. Okay, but when it degrades, okay, it loses that solubility. Then it can move out of the water system. Okay, and then it will gather at the bottom of the container, for example. For example, like protein drinks. Okay, you don't want to have sedimentation at the bottom of the protein, for example. Okay, because when it denatured, then that will happen, the loss of solubility. Okay, so this is also what also happens when protein degradation occur. And then loss of water binding. Okay, so water binding is one of the most important property for meat products. Okay, whether it is if it is intact meat, for example, like poultry, okay, intact meat, or in communicated products. Okay. Where, for example, like sausages, where the microstructure of the product has been changed. Okay, so when there is loss of water binding capacity, then the product will lose water. And as we have discussed previously, the meat, okay, product, intact meat, okay, depends on water because it is based on weight. So the loss of water means the loss of weight, and also subsequently the loss of profit. So water binding is very important. And when there is loss of water binding, then the meats will become drier. Okay, the less juiciness, less soft or tender. So it will become hard and dry. So that is not desirable to the consumers. Okay. And then also proteolysis, okay, due to proteolytic enzymes. Proteo means protein, lysis means the cutting of proteins, okay. These enzymes will break down collagen and also elastin. However, in poultry, it is not as important as in meat, okay, because poultry in general, it is considered as a tender meat, okay. It is not really that tough, okay. So we don't have that much problem with tenderness when it comes to poultry. So proteolytic enzymes does not play a significant role in poultry. Okay, and then of course there will always be microbial activity. Okay, and then low temperature reduces the degradation rate. Okay, so let's look at the sources of poultry degradation. Okay, first is enzymes. Okay, we have discussed just now proteolysis. Okay, proteolysis, the cutting of proteins. However, okay, however, in poultry it is not as important because remember when in meats, okay, especially in Western countries, okay, when they have slaughtered the meat and processed it, okay, the whole carcass, okay, the whole animal after it has been, the skin has been removed, okay, 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 has been removed. Ada yang nak bertanya ke? Zarina? Okay. If anybody wants to ask, just straight away ask. Okay. No need to raise your hands. Okay, so straight away asks like Chung just now. Okay, so let's go back to our discussion. Okay, so enzymes, okay, proteolysis. For meat, it is important because we want the meat to be tender, especially in the Western countries after slaughtering and then removing the skin and also the organs, the internal organs. Okay, they will put it at low temperature so that the proteolytic enzymes will degrade the connective tissues, that is the collagen and also the elastins. Okay, so that will produce a more tender meat, and especially, for example, like in steaks. Okay, when we are eating steaks, so tenderness is a very important property of the products. It is less important in when we are using it to cook for curry, for example, for korma, for example. So tenderness is less important because the heat, okay, will degrade, okay, the protein, the meats. So it is less of a concern. But when we are talking about foods that are like steaks, for example, okay, so tenderness is important, okay, and these are like premium or higher, more expensive products, and this will increase the profit for the food manufacturers. Okay. 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 So and then secondly is physical. Okay, physical sources of poultry degradation. The loss of water we have discussed just now. It is important so that we won't lose the juiciness and also reduction of yield weight. Okay. And then about the biochemistry, okay, similar to meat, okay, lipid oxidation and also undesirable odor. Okay, so lipid oxidation, okay, in meat it is more important. In poultry it is less important because poultry itself is considered as a low lipid or low fat protein. Okay, so the amount of fat is lesser, okay, significantly less compared to meat. So lipid oxidation is less of a concern, but it can still happen if you were to store if you were to store it for a longer period of time. Okay, also due to lipid oxidation, there will it will become rancid, okay, and the production of undesirable odor. Okay, microbiology, okay, very important, okay, because the majority of food degradation is due to microbiological factors. Okay, okay. When we talk about poultry, it is first and foremost salmonella. Okay, for all of you, you have to remember this. Okay, as food scientists, okay, we have to remember this, that when it is poultry, when it is asked about the what are the type of microbes that is common in poultry, then salmonella has to be automatic. Okay, automatically comes into your mind. Okay, because it is very connected to poultry. Okay, salmonella. Okay. 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 So pathogen, it is a pathogen. Pathogen meaning that it is dangerous. Okay. It affects the health of consumers. Okay. Non-pathogens meaning that they are also microbes. Okay, but they do not affect the health of the consumers. Okay. For example, like yogurts. Okay. It is due to lactobacillus species, but it is a non-pathogenic bacteria. Okay, so salmonella is one of the pathogens. Okay, others such as Pseudomonas, Micrococcus, Streptococcus, and others. Okay, preservation of poultry using chilling. Okay, first and foremost, as we have discussed previously, reduction of initial microbial counts. Okay, so this is very important. Okay, any type of food preservation step, this is the first and foremost step that the industry or the company has to take. Okay, and we should never discount this this factor. Okay, it is very important. Okay, initial microbial counts, okay, lesser, then the degradation rate also will be lesser, and that will reduce the burden of preservation on our preservation technique or preservation method. Okay, so our preservation will be more efficient and more cost effective. Okay, that will in turn produce higher profit. Okay, so it is very important. Okay, then sources of contamination: dirt, feces from the feet, feathers, intestines. Okay, repeated use of water facilitates contamination. Okay, commonly when processing poultry, okay, after defeathering, for example, the carcass will be uh, put into a water bath, a continuous water bath. Okay, for cleaning. Okay, and in this water bath, okay, it is a potential opportunity for contamination. For example, if one of the bird, okay, or the chicken is contaminated due to rupture of the intestines, for example, then when this bird, okay, this chicken is being put into the water bath, then it can contaminate the water bath and also contaminate the other chickens. Okay. Okay. So that is meant by repeated use of water facilitates contamination. So what are the steps that we should take to reduce, okay, the contamination? Okay. For the water, we will add chlorine. Okay, and also using low temperature, again chill temperature, by the addition of ice or other methods. Okay, but to lower the temperature and to add chlorine so that we reduce the risk of cross contamination. Okay, can we totally eliminate the risk? The answer is no. Okay, but what we do is to manage the risk. Okay, reduce it as much as possible. Apart from that, okay, of course, this is a must. Okay, personal hygiene, sanitation, and good manufacturing practices. Okay, storage temperature similar to meats, and basically all chilling temperature will be between 0 and 5 degrees Celsius. Okay, important to have a low temperature control. Temperature abuse, okay, will result in the reduction of storage period and also security risk. Okay, another important aspect is our products needs to be wrapped to reduce water loss. Okay, because at lower temperature, okay, then the relative humidity will also drop. Okay, so when we have the moisture content in our poultry is higher compared to the environment at low temperature, because the relative humidity means the amount of water in the air. Okay, amounts of water in the air. When we reduce temperature, okay, then in general, okay, the relative humidity or the amount of water in the air will also decrease. Okay, will also decrease. Okay, then what will happen is that the moisture that is higher in the poultry, okay, will migrate out into the air. Okay, into the air, that will cause dehydration of the poultry. Okay, so we need to wrap it. Okay, and also in cut poultries, okay, in cut products, for example, the thighs, okay, or the breasts, okay. So in these cut products, okay, usually the problem is syneresis. We call it as syneresis, where liquid will flow out, okay, out of the, even though the meat is still intact, but because it has been cut, so there is we have damaged the microstructure. Okay, so what will happen is that there will be a flow out of liquid from the cut product into the surrounding. Okay, so that's why usually we will put absorbents, okay, like diapers. Okay, so if you were to go to the supermarket or the hypermarket, just go buy, like, for example, chicken breasts, okay, that has been chilled, then you can see that below the product, that is like a piece of absorbent, okay, or like similar to diapers. Okay, so that is to absorb the liquid that flows out due to syneresis. Okay, and then we also how do we package it? Okay, similar to meats. Okay, 3 types of approaches. One is aerated packaging or air packaging. Okay, so basically it's just put the products, okay, with the absorbents into a container and then wrap it up. Okay, so that will so the composition of air inside the package is similar to the composition of air outside of the package. Okay, so it contains oxygen, so it allows the aerobic microorganisms to grow, for example, Pseudomonas, and it will also allow oxidation to take place. Okay. Okay. However, for poultry, okay, the existence of oxygen is less of a concern. Okay, apart from the growth of, I mean, from the viewpoint of the color. Okay, because poultry, chicken, we don't need to be red in color. Remember, for meats, okay, we want it to be red in color, because the consumers, when they see the color red for meat, then they connect it, they refer to it being fresh. Okay, but for poultry, we don't have that kind of connection. Okay, so whether we have oxygen or not, the color of the product will still be the same. Okay, so vacuum packaging, okay, blocks the growth of aerobic microorganisms, okay, significant microorganisms such as lactobacillus, okay, but the problem will be similar to meat, pressure. When there is atmospheric pressure pressing on the product, then that will increase the fluid excretion due to syneresis. Okay, basically not desirable to look at. Okay, and then it will create microenvironments, okay, with high water activity, okay, for microorganisms to grow. Okay, it's not a problem for color. Okay, it also blocks oxidation because there are no oxygen, because you have sucked all the oxygen or all the air out of the package. Okay. Okay, and then gas packaging. Okay, gas packaging uses CO2. Okay, blocks the growth of aerobic microorganisms. Okay, Salmonella also is restricted. Okay, Lactobacillus, because it is a facultative anaerobe, okay, it will be significant. It blocks oxidation, okay, but as we have discussed, it is more costly. Okay, okay, okay. So, okay, so that is for poultry. Okay, the next one. Okay. Okay, so the next one will be, okay, the next one will be, okay, seafoods. Okay, any questions for poultry? Okay, so let's go to the next product. Okay, seafoods. Okay, so let's look at the post-mortem chemistry. Okay, similar to meat and also poultry. Okay, after death. Okay, post-mortem. Okay, glycolysis will happen. Will start to happen where glycogen will be converted to lactic acid. Okay, the final pH will be around 6 to 7. Okay, the decomposition. Okay, the first phase of degradation. So microorganism is adjusting. Okay, adjusting themselves to grow. Okay, decomposition of inosine monophosphate or IMP and also hypoxanthine. Okay, will occur. IMP and hypoxanthine is the desired flavor components in fish. Okay, in fish or seafoods. Usually in Malaysia we call it as, for fresh seafood, usually we call it as rasa manis. Right? Okay, so if it is fresh, then we say that, oh, this is rasa manis. Okay, but actually it is not due to sugar, the sweetness or the freshness. It is due to IMP and also hypoxanthine. Okay, but when the fish starts to or the seafood starts to degrade, then IMP and hypoxanthine will be degraded or decomposed. Okay, so that will result in the loss of fresh flavor for the fish. Okay, and microorganism activity, microbial activity from the intestines and skin. Okay, this is usually during the second phase of degradation. Okay, for example, Pseudomonas, Ultramonas, etc. Okay, food spoilage, for example, what we usually observe is there will be development of mucus, okay, and then discoloration and also odor. Okay, another important chemical is what we call as TMAO, trimethanolamine oxide. Okay, so this will also undergo decomposition and then will produce trimethylamine, and this is the undesirable odor. Okay, the undesirable odor. So one of the method of to chemically analyze for to see to what extent that seafood degradation has occurred is to measure the trimethylamine. Okay, okay, and then for pathogen, okay, many pathogens, okay, it depends on where the fish lives, okay, or have lived, okay, before it is being captured. Okay, so it depends. That's why I think a few months ago, okay, there have been a warning from the government about red tide. Okay, about red tide. Okay, so it will affect the fish, kind of toxin. Okay, that will make the fish, okay, dangerous for us to consume. Okay, so among the pathogens that we are concerned with is Clostridium botulinum type E. Okay, Clostridium botulinum has many types, A, C, E, if I'm not mistaken. Okay, so but type E is more commonly found in seafoods. Okay, more commonly found in seafoods. Okay, Clostridium botulinum is a pathogen, meaning that it affects the health of consumers. Okay, the only thing is that the majority of pathogens, they are proteolytic. Okay, meaning that proteolytic means that what we have like we have discussed previously. Proteo means protein, lytic means cutting. Okay, so when protein is being degraded, then it produces a very undesirable odor. Okay, so that's why sometimes, like for example, if you have experiences having a dead mouse in your house or somewhere or outside of your house, okay, then you can really smell a very undesirable odor. So among the causes of that odor is the degradation of protein. Okay, degradation of protein. However, for this particular pathogen, okay, the uniqueness of it is that it is non-proteolytic, meaning that when it is non-proteolytic, it did not produce undesirable odor. So the problem is that usually for food, when we want to eat a certain type of food, and when it gives out an undesirable odor, then we will throw it away. Okay, yeah, we call it as basi or spoiled. Okay, so that actually serves as a warning to us, as an indicator to us that this food has turned bad and it should not be consumed. Okay. However, for Clostridium botulinum, because it is non-proteolytic, it does not, even though it is growing inside the food and producing toxins, but it does not produce an undesirable odor. So the concern is that if consumers may look at it as if the food is still okay, it's still safe, and then consume it. Okay, so this is something that is of concern. Okay, then we look at the third phase. Okay, food, okay, in a spoiled state or toughness. Okay, it's tough, dry, and sticky, meaning that the texture is not desirable at all. Okay, and then fourth phase is unacceptable condition. Okay, you can't mistake this condition. Okay, definitely it is very clear. Okay, and it is not fit for consumption. Okay, fishes that are high in fat, okay, naturally undergoes oxidation. Okay, remember, maybe you have not learned about this. Okay, because in food chemistry, okay, one of the things that you will learn is that fat or lipids or oils, all of these are the same. Okay, basically the same component. Okay, when it is exposed to oxygen, it will undergo oxidation. And one of the products of oxidation is components that will produce a rancid odor. Okay, a rancid. Okay, in Bahasa Melayu, we call it as tengik. Okay, remember, if you have any experience eating kerepek ubi or kerepek pisang that you buy at the stores, and then when you eat it, there is a strange taste to it, and also accompanied by a strange smell. So that is what is referred to as tengik or rancid. Okay, tengik or rancid. Okay, so that is due to the oxidation of oil. Okay, in the case of kerepek, because it is fried, so it absorbs oil, and during storage, because it is not packed in airproof, okay, airproof or oxygen-proof packaging, then okay, oxygen will causes oxidation and subsequently the rancid odor or the rancid and also the rancid tastes. Okay, so low temperature will reduce the degradation rate. Okay, what are the effects of low temperature on seafood microorganisms? Okay, so because microorganisms is important, okay, in any preservation situation, because the majority of food degradation is caused by microorganisms. Okay, what are the effects of low temperature? When we lower the temperature, what will happen to how does the microorganism reacts? So it depends on its original habitat. Okay, certain microorganisms, okay, are at different habitats, okay, different environments. There will be different microorganisms, and also we have discussed 2 weeks ago that microorganisms, they can be divided into several categories depending on how the temperature that they live. Okay, for example, we have mesophilic, that is usually at room temperature, and then we have psychrotrophs, okay, where it can withstand lower temperature. We have psychrophiles, where it lives, okay, lower temperature, thermophiles, where it lives, okay, high temperature. So all based on temperature, we have all these categories for microorganisms. Okay, so seafood from warm marine habitats. Okay, so when the seafood lives in the warm marine habitats, of course, we would expect that the microorganisms that is present, okay, in that particular seafood are microorganisms that are adaptable to warm water, warm temperature. Okay, so usually it will be mesophilic. Okay, aromonas, for example. Okay, so when we and because microorganisms, mesophilic microorganisms are more adapted to living in at warm temperature, then when we apply low temperature, then it cannot adapt. Okay, so the effect of low temperature is more pronounced, more significant for microorganisms that are uh, uh, for microorganisms in seafood that lives in warm environments. Okay, but for seafood from cold sea, okay, lower temperature, then the microorganism that we can find, okay, on that particular seafood, okay, be it fish or squids or prawns, okay, so that is suitable to live at lower temperature. So maybe there are psychotrophs or psychrophiles that have adapted to living at lower temperature. So when we apply low temperature, okay, the effect is less significant. So we have to apply a lower temperature. Okay. Okay, and then preservation of seafoods using chilling. Okay, so so similar to poultry and also to meat. Okay, again, I would like to emphasize very, very important. Okay, so very, very important. Do not overlook this. Okay, reduction of initial microbial counts. Okay, so it looks simple, but it is very, very important. Okay, so initial microbial count, if it is lesser, then the rate of degradation also will be lesser. Okay, source of pollution, habitat of origin, okay, the intestines, okay, squeeze, okay, for example, okay, like when when the fishes are caught, they are usually caught using nets. So and then they will be hauled up onto the boats. So the fishes that are at the very bottom of the net, then they will experience very high pressure due to the weight of the other fishes on top of it. So that may cause the intestines to be squeezed and ruptured, and the insides of the intestines, which is of course, as we all know, contains a lot of microorganisms that can contaminate the other fishes. Okay, so and then also the tools and also the workers. So that's why it is important to practice personal hygiene, sanitation, and also good manufacturing practices. Okay, so what are the storage temperature? Okay, as usual, 0 to 5. Okay, low temperature care is important. Okay, temperature abuse will result in the reduction of storage period and also security risk. Okay, it needs to be packaged, okay, to reduce water loss from the products. Okay, all chilled and frozen foods have to be packaged. Okay. Okay, aerated packaging. Okay, normal packaging. So basically it is it allows the growth of aerobic microorganisms because it contains oxygen and also the oxidation of fatty fish. Okay, fatty fish. Also, although fishes are also considered, like poultry, a low-fat protein, but certain fishes, okay, contains higher amount of fats. Okay, it is higher amount of fat. Okay. Okay, vacuum packaging. Okay, again blocks the growth of aerobic microorganism. Okay, the threat of growth of CBOT. Okay, type E, Clostridium botulinum type E. Okay, because Clostridium botulinum is anaerobic. It can grow even without oxygen. So when we use vacuum packaging, okay, it pulls out the air, but CBOT can still live, can still grow and produce toxins. Okay, and because it is quite common in seafood, so that is why it is a concern here, where when we use vacuum packaging. Okay, usually in any situation, microorganisms, okay, in any location, there will be many types of microorganisms growing, okay, in the same location. So they have to compete between themselves. They have to compete for space. They have to compete for nutrients. Okay, they have to compete for water, for example. Okay, so they have to compete. And in general, okay, usually the spoilage microorganisms will outgrow the pathogens. Okay, usually. So even spoilage microorganisms are microorganisms that will cause damage, that will spoil the foods, but they are not detrimental to the consumer's health. Okay, they do not affect the consumer's health. Okay, so these are what we call as spoilage microorganisms. They spoil the food, but they are not a threat to our health. Okay, so usually these spoilage microorganisms, they will outgrow, okay, and then spoil the food, okay, and then we say, okay, this food is bad, so I'm not going to eat it. Okay, so in that step actually saves us, okay, from taking in toxins, okay, and affecting our health, okay, due to the pathogens that is inside the food. Okay, however, the majority of the spoilage microorganisms are aerobic. So when we vacuum pack, okay, we pull out the oxygen. So the majority of the spoilage microorganisms cannot grow, even though it is good. But now, okay, for anaerobic pathogens, now they have less competition to grow. Okay, so that is the concern. Okay, less competition to grow. So now, without the competition, without of the aerobic spoilage microorganisms, then these pathogens can grow at a higher rates. Okay, and that is a health concern to the consumers. Okay. Okay, so usually for seafood products, usually it is not recommended, okay, to vacuum pack. It is safer not to vacuum pack, okay, even though it is not wrong to do it, but we have to be more careful. Okay, so does not produce odor, gives the impression of not being damaged. Okay, so no aerobic microorganisms, no competition, okay, and also no odor, okay, because the spoil odor, okay, is commonly being produced by the aerobic spoilage microorganisms. Okay. Okay, and then due to the pressure, because of the vacuum, okay, then there will be syneresis, fluid extraction, undesirable appearance, similar to what we have discussed previously. Okay, and then growth location for microorganisms. Okay, but it blocks oxidation. Okay, for vacuum packaging. For gas packaging, okay, similar issues to vacuum packaging. Okay, but it is also more expensive. Okay, so that is how we preserve seafoods using chilling or low temperature. Okay, any questions? Okay, so if there's no questions, then we'll proceed to fruits and vegetables. Okay, this is the last products. Okay, so look at the post-harvest chemistry. Okay, so we don't call it as a post-mortem because we don't consider fruits and vegetables as living organisms. Okay, so we call it as post-harvest, meaning that after we have separated it from its parent plants, or we have pulled it out, okay, for processing, for consumption. Okay, for fruits and vegetables, most of them, okay, will continue to respire, to undergo respiration, okay, even after they have been separated from the parent's plants. Okay, we have plucked them out, okay, but still they are respiring, okay, undergoing respiration. Okay, so respiration is the production of carbon dioxide, uptake of oxygen, and also production of water vapors. Okay, similar to us breathing. So the fruits and vegetables, they will continue to breathe even after they have been harvested. Okay, so similar to us, we take in oxygen and then we produce carbon dioxide and water vapor. Okay, two types of fruits. Okay, basically we call it as climacteric. That is, it is able to ripen after harvesting. Okay, bananas, mangoes, for example, versus non-climacteric. Okay, it is not able to ripen after harvesting. Okay, so respiration continues, and then there will also be physical changes. Okay, so after it has been harvested, okay, softer texture. This is during ripening. Sorry, during ripening, there will be physical changes. Okay, softer texture. Okay, where there will be pectin enzyme reaction. Okay, so when we were to look, let's just take an example. A banana, for example. Before it ripens, then the texture, okay, is very hard. Okay, it is very hard. We can't eat it. Okay, it is very hard. Okay, but when it starts to ripe, when it ripens, then the texture will become softer. The taste before it ripens, it is sourish. But after it ripens, then it becomes sweeter. Okay, so basically these are the physical changes, okay, that happens during post-harvest. Okay, post-harvest, especially for climacteric fruits, because it is able to ripen after harvesting. Okay, so what happens is that for the texture, previously, okay, the texture, it contains a lot of pectin. Pectin contributes to the hardness or the toughness of the structure. Okay, but when it starts to ripen, then pectin enzymes will be produced, and it will react. Okay, will react on the texture, will react on the pectin. Okay, degrades the pectin, and what we observe will be a softer texture because there is less pectin. Okay, and then also color change. Okay, and the strength depends on the cell wall as well as the hydrostatic pressure. Okay, it means that okay, for us living beings, animals, humans, okay, our strength, okay, or our rigidness, okay, to be using a better word, our rigidness depends, is due to us having bones. Okay, the bones are propping up our physique. Okay, tulang ni yang memberi kita kekuatan. Okay, okay, tetapi but for plants, okay, they do not have bones. Okay, they do not have bones. So how does the plants stay upright? Okay, or have a certain physical strength? Okay, that is due to the cell walls. Okay, and also the hydrostatic pressure. Okay, remember when during your SPM, okay, comparison between animal cells and plant cells. Okay, animal cells do not have cell walls; they only have cell membranes. Okay, why? Because their rigidness is dependent on the bones that they have. But for plants, they do not have bones, so their rigidness depends on the cell walls. Okay, and one of the main component of cell walls is pectin. Okay, so pectin gives them the rigidness. Okay, So when the enzymes, pectin enzymes decrease the pectin, okay, then the texture becomes softer. That's what happens when fruits ripens. And also there will be a higher production of glucose. That's why ripe fruits are more sweeter than compared to unripe fruits. Okay. Okay, and then also there are microorganisms, okay, exposed to sources of microorganisms, air, soil, water, insects, etc. Okay, so it depends on where it is being planted, how it is being harvested. Okay, are there other animals in nearby that will contribute to the contamination? Okay, so low temperature reduces the rate of reaction and also the rate of respiration. Okay, the rate of reaction and also the rate of respiration. Okay, over here you can see, okay, when we reduce the temperature, this is the respiration rate. When we reduce the temperature, meaning that we are moving from the right to the left, okay, because this is the temperature. So you can see the rate of respiration is reducing. Okay, although they do not reduces in parallel or at similar rate, but all of them are reducing. Okay, so this is the respiration. So the lower the respiration, the lower the temperature, the lower the rate of reaction, and also the lower the rate of respiration. So when there is a lower rate of respiration, aging also becomes slower. Okay, so when it becomes slower, aging becomes slower. So then we are increasing its shelf life. Okay, for example, like we take banana. Okay, if it is at normal temperature, then after 1 week, for example, after 5 days, then it will ripen, and after that it becomes overripe, and then you have to throw it away. However, if we are using chilling, then the rate of ripening for that banana is being slowed down. So it takes more time for it to ripen. Okay, so that will increase the shelf life of the products, and it will also increase the 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 the, the distance that that particular product can travel. Okay, for example, if you want to send it from Malaysia to the United Kingdom, for example, using using ships, then it will still be possible because the ripening rate is slower. Okay. Okay, so sources of fruits and vegetable degradation, first and foremost, enzymes. Okay, in fruits and vegetable tissues, okay, it is inherent. It is naturally occurring. Okay, occurring that there are enzymes, okay, inside fruits and vegetables. Pectin enzymes, okay, the aging process, we have discussed this just now. It will degrade the pectin inside the cell walls, okay, causing a softer texture, okay. But too much will cause physical damage. For example, overripe. Okay, so it is from firm, the texture firm to ripe, okay, which is desirable, not too hard, not too soft. But when it goes overripe, then it is too soft, where it is not preferable to consume it. Okay. Okay, and then also polyphenol oxidase. Okay, so this is a very important enzyme. All of you should remember this. It is polyphenol oxidase, or what we call as PPO. Okay, polyphenol oxidase. Okay, uh, in food there are 4 types of browning. Okay, 4 types of browning. Browning is a process where the food changes color from fair, okay, or whitish to brownish. Okay, sometimes it is desirable, sometimes it is not desirable. Okay, for example, if you were to cut bananas, okay, initially when we started to cut the bananas, it is white or fair in color, but after some time it will turn brownish. Okay, it is not a health concern. Okay, we can always it is safe to be eaten, but when we produce products to the consumers, it is less desirable. Okay, because for our products, we want it to have a clean or a desirable appearance to the consumers. Okay. Okay, so what happens to polyphenol oxidase? Okay, four types of browning. Sorry, four types of browning. Three types are non-enzymatic, meaning that it does not involve enzymes. Only one is enzymatic browning, and that one enzymatic browning is caused by polyphenol oxidase. Okay, so what really happens? Okay, so polyphenol oxidase is inside the banana. So let's just take an example of bananas. Okay, so it is inside the banana, but it does not cause, when you first peel the bananas, it is still whitish in color. So even though there is PPO, it does not cause browning. Why? Because PPO will act on phenolic compounds. Okay, that's why it is called a polyphenol oxidase. It oxidizes phenolic compounds. Okay, so when the microstructure, when the banana is still intact, okay, the microstructure is that PPO cannot react with the phenolic compounds, so there is no browning. But once we cut it, then we are damaging the microstructure. So now the PPO is able to react with the phenolic compounds, thus producing the brown color. Okay, so that is what is called enzymatic browning. The other types of browning that is in food, that occurs in food, is what we call as a Maillard reaction. All of this you will learn in food chemistry. Okay, I'm just stating it. Okay, Maillard reaction, where, for example, we have meat. Okay, and then we cook it, then the color changes. Okay, so it is a reaction between amino acids, okay, with reducing sugars, okay, that produces brown color. And then there is also caramelization, okay, or in Bahasa Melayu we call it as gula hangus, okay, where we put in sugar, and then we heat it up, so it will change from clear or white color to brown. Okay, so that is caramelization. Caramels are common ingredients in drinks and also in foods. Coca-Cola, cola drinks, for example, the blackish color, that is due to, among others, contributed by the addition of caramels. Okay. Another one is the oxidation of ascorbic acid, okay, or vitamin C. Okay, so over here, what we are more concerned about is the PPO, the enzymatic browning. Okay, so those are one of the threat factors or the degrading factors for fruits and vegetables. Okay, and then physical moisture transfer. Okay, if we mentioned just now that moisture is important in meat products, but in fruits and vegetables it is 10 times important, because remember, okay, the rigidness of the fruits and vegetables depends on the cell walls and also the hygroscopic pressure of water that is inside the cells. Okay, so that's why vegetables or plants that do not have enough water, that it will start to becomes limp, okay, layu, okay, because loss of water. But when we add water, then it becomes rigid, more rigid again. Okay, so loss of water from the product to the environment, okay, texture drying, okay, and also surface crackings. Okay, water absorption by products from the environment. Okay, so for fruits and vegetables, we do not want it to lose moisture, okay, because it will affect the texture and also the appearance. Okay, however, for certain fruit products, okay, we do not want it to absorb moisture from the environment. Okay, what type of product? Like dried fruits, for example. Okay, so dried fruits, Okay, for dried fruits, okay, it contains a very low moisture content. So if you were to expose it to the environment, okay, especially over here in Malaysia, okay, because we have a higher relative humidity, meaning that in the air around us, there is uh, a higher amount of water vapor, okay. So that will cause the water vapor from the surrounding to be absorbed into these dried products. And what happens is that the water activity in that dried product will increase and will allow the growth of microorganisms. Okay. Okay. So softer texture. Okay. It will cause water absorption, like I mentioned just now. Softer texture, increased water activity, and then fungal growth. Okay. Another degradation, okay, that involves fruit and vegetables is from the biochemistry point of view. For example, like oxidation, fat content. In general, okay, it is very low in fruits and vegetables. Okay, but important during storage, because during storage, then uh, there is it involves a longer time. Okay, so it may allow, okay, the action of enzymes, like for example lipoxygenase. Okay, even though in general the fruits and vegetables contain low fat content, but certain fruits and vegetables also has high oil content. For example, like avocados, for example, okay, contains a higher fat content. Okay, and then certain fruits and nuts, for example. Okay, so that is why sometimes if you were to store too long certain nuts, then it will become rancid because of the oxidation. Okay. Loss of flavor components. Okay, certain fruits, for example. Okay, loss of flavor after cooking. Okay, uh, okay, re, related to certain reduction of compounds. Okay. Okay, and then okay, related to, sorry, this is genetic cooking. I used the wrong word. Okay, this is a loss of flavor. Okay, after ripening. Okay, okay, to the reduction. Okay, to the reduction of 2,4-decadienoic acid esters. Okay. And then microbiology, microorganisms. We have spoilage and pathogens. Okay, we have discussed this just now. Okay, it depends on the surroundings. Okay. Okay, how do we chill fruits and vegetables? Okay, again, reduction of initial microbial counts. Okay, the lesser the better. The better the preservation. Okay, sources of pollution. It depends on where it is being grown. The environment, air, soil, insects, water, animals in the environment, and also how is it being processed? How is it being handled? The workers, the tools, etc. The premises. Okay, personal hygiene, sanitation, and good manufacturing practices are very important. Okay, however, even though we know that when we subject, okay, the fruits and vegetables, okay, to lower temperature, then what happens is that the rate of respiration will also decrease. So when the rate of respiration is lower, then uh, the aging process, the ripening will slow down. Thus, we will have a longer shelf life. Okay. However, another issue, important issue is what we call as chill injury. Okay, chill injury, especially in tropical fruits. Okay. Chill injury, it is not a health concern, but it is not a safety concern. It is more of a quality concern. Okay, because when chill injury occurs, then the fruits will have depending on the different type on the type of fruits. Okay, certain fruits will have abnormal change in color. Certain fruits will have an abnormal development of foreign flavors, for example. Okay, examples such as bananas. Okay, if you were to put bananas inside our refrigerators at the chill section, it will stay longer, definitely. But once we take it out, then you can see that the color will change drastically. Okay, and there will be like darkish spots, for example, or the brownish of the whole banana. Okay, so this is not natural and it is not desirable. So that is the setback of chilling fruits and vegetables. Okay, tomatoes. Examples are like if you were to chill tomatoes for a long period of time, then after some time, you can taste uh, an off flavor. Okay, an off flavor. It is not like tomatoes. It's not nice. Okay, off flavor. Similar to cabbages, for example. Okay, also has been reported that if it is being stored for too long, even though the appearance, the texture is still the same, okay, but there is an off flavor that can develop, okay, which is also not desirable. Okay, so that is the main issue, and especially for tropical fruits. Okay, why does this chill injury occur is not really understood, but it is postulated to be due to the physiology of that particular fruit or vegetable. Okay, because it more commonly occur in tropical fruits. So because the theory is that the physiology of tropical fruits are more adapted to warm temperature as opposed to a chill temperature. So when it is subjected to a chill temperature, then it is it goes haywire basically. It doesn't function in the normal manner. Okay. And then another issue is that for chopped fruits, okay, nowadays we can see a lot of products where in a container you have different types of fruits, but a little bit from each type of fruit. Okay, as opposed to this is like a ready-to-eat product, fruit products. Okay, so as opposed to buying a watermelon, a whole fruit, and then not knowing what to do with it because it is too much. Okay, for example, you are living alone, so it is more preferable, more convenient to just buy mixed fruits. Okay, a little bit of watermelon, and then you have grapes, for example, a little bit of a pear, and then oranges, like that. Okay, but the problem is that when for fruits, when we chop them, okay, so we destroy the microstructure and then syneresis starts to happen. Okay, so we have discussed this. Similar to what we term as syneresis is the outflow of fluid, okay, from the fruits. Okay, so undesirable appearance, okay, location for microbial growth. Okay.
Doctor,
Yeah.
for the tropical fruit and the tomatoes, does it mean that they are suitable or to be kept in the room temperature surrounding?
Basically, for bananas, okay, usually we prefer to be kept at room temperature, or if it is at lower temperature, just slightly lower temperature. But even then, it have a limited time span. Okay, cannot be too long, then chill injury will occur. Tomatoes, because it is from a temperate climate, so it can withstand lower temperature better compared to bananas. So we can store them at lower temperature for a longer period of time compared to bananas. Is it okay?
Okay, thank you, Doctor.
Okay. Okay, aerated packaging problems as above, as we have discussed this. Okay, all of these are the problems because of course there's no difference aerated packaging because the composition of air is still the same. Okay, as outside of the package. Okay, so for gas packaging, okay, usually they will use CO2 plus O2. Okay, vacuum pack rarely being used. Okay, uh, okay, use of CO2 plus O2. Okay, most often used. Okay, it blocks the growth, not really blocks. I don't think that I should use this. Okay, it reduces the growth of aerobic micro organisms. Some still can because can grow because you still have O2, but it reduces the growth of aerobic microorganisms. Okay, high CO2 concentration lowers the rate of respiration. Okay, usually like for meat and poultry and seafood, for gas packaging, it is quite common to use CO2 only without the addition of O2. But usually for fruits and vegetables, because they are still breathing, okay, we want it to have a certain amount of oxygen. Okay, so that anaerobic conditions do not occur. Okay, so that there will not be any growth of anaerobic pathogens. Okay, no competition from other microorganisms. Okay, so this is important because usually fruits is what we term as an RTE, ready to eat food products. Okay, RTEs. Okay, ready to eat food products. So it is risky. Okay, if there is a possibility of anaerobic pathogens that can grow. Okay, because like I mentioned just now, spoilage microorganisms, even though we don't like them, but actually they are quite beneficial as uh, as a hurdle or a warning or an indicator that we should not eat that food. So if it is totally anaerobic or it doesn't contain any oxygen, so there will not be any competition from other microorganisms. So growth of anaerobic pathogens will happen at a higher rate, and that is dangerous because there is no these products will be directly eaten. Okay, so no heat treatment. Okay, so there is no safeguarding step. Okay, before consumption. Okay, and also when there is totally no oxygen, then we will create something what is called as an what will happen is what we call as an anaerobiosis. Okay, anaerobiosis is when because the fruits and vegetables are still respirating. Okay, it is still undergoing respiration, but there is no oxygen. Okay, so when that happens, then okay, aldehydes and ketones will be produced, and this will contribute to undesirable flavors. Okay. Okay. So what are the issues? Okay, of food preservation. Okay, using chili. Okay. Cold chain. Okay, cold chain is the preservation of the maintenance of low temperature throughout the distribution. Okay, so it is important. Chilling, minimally preservation method. Okay, that's why it is popular because it only imparts minimal preservation to the product. Okay, so the product basically is 70-80% the same as before it is being preserved. However, it also because of that also it is unstable. Okay, it is unstable. Okay, short shelf life, for example, 10 to 14 days only. Okay, refrigerated products need to go through various phases and situations. Okay, let's look at this diagram. Okay, for example. Okay, so these are the what we call as marketing channels. Okay, for consumer goods and services. Okay, for example, there are several types. Okay, sometimes from the producer straight to the consumer. Sometimes from the producer to the retailer, then only to the consumer. Sometimes from the producer to the wholesaler first, then to the retailer, and then only to the consumer. Or producer to agents, wholesaler, retailer, and lastly consumer. Okay, so regardless of this, the low temperature has to be maintained. Okay, so that is what is meant by cold chain. Okay, we have to maintain low temperature. Okay, along the different stages of distribution from the producer to the consumers. Okay. Okay. Okay, that's the cold chain. Okay, and then okay, so due to the lack of stability of the food system, okay, so it is highly dependent on maintenance of low temperature. Okay, so the term is what we usually use is temperature abuse. Okay, meaning that to give the opportunity for threat factors, that it will give the opportunity for threat factors to spoil the food because the temperature is not low enough. Okay. Okay, issues. Another issue is the dependence on temperature. Okay, the preservation. Okay, preservation by chilling. So it is highly dependent on temperature. So no or very few other preservation methods. Okay, for example, chemical substances, which you have learned okay previously. So it is being directly consumed, or very minimal cooking. So risk of pathogen. Okay, if that is temperature abuse. Okay, so that is the main issue. That is one of the issues of chilled products. Okay, and then increase storage time. Okay, the extension of storage period. Okay, this is what we want actually. Okay, because for the preservation of food, we want to increase the shelf life. Okay, we want to increase the storage time. Okay, however, when there is increased storage time, it is beneficial to us, the consumers. It is beneficial to the retailers, because then the product can still be sold. Okay, it won't be thrown away because of it has passed its expiry date. Okay, so beneficial also for the producers. Then they can distribute it to at a longer distance further. Okay. However, increased storage time also is beneficial to the pathogens, because now they have enough time to grow and produce toxins. Okay. Okay. So formally, short-term storage. So psychotrophic meaning that pathogens that can withstand low temperature. So psychotrophic pathogens grow, but they grow at a slower rate, right? Because at a slower rate, because there are competition, etc. So they do not reach a dangerous level. Okay, but with new technology, with lower temperature, so the shelf life is longer. So psychotrophic pathogens, even though they grow slowly because of the lower temperature, but they can still grow and can reach the level of danger. Okay, where they are able to produce toxins or to infect consumers. Okay, psychotrophic pathogens such as Listeria monocytogenes, Yersinia enterocolitica, and also, like we have discussed, Clostridium botulinum. Okay, Okay, so an example. Okay, so if, for example, at for the black dots, okay, the pathogen grows, okay, but it is at air storage. So now after this, after 15 days, then it is the end of the shelf life. Okay, because spoilage microorganisms has grown, so producing undesirable odor. So now the product is not consumable anymore. Okay. However, at lower temperature, for example, the white dots, okay, because the shelf life is longer, so now this Listeria monocytogenes, now even though it is growing at a similar pace, but because the time is longer, then now it can reach a dangerous level. Okay, so it is a two-edged sword where it cuts both ways. From one aspect, a longer storage time is favorable. Okay, but at the same time, it also poses as a risk. Okay, so that is why we need to know our products and how do we address all these issues. Okay, another issue also is regarding the manufacturer. Okay, other preservation methods, okay, require large equipment, special premises, controlled environments. Okay, for example, in canning in the factory, to do canning, then you need a factory. Okay, and you need high temperature, so high heat, then meaning that you need to produce steam. Okay, so you need a boiler, for example. So all of this, okay, big, huge equipments, okay, special places. But because chilling is a minimally processed, is a minimal processing method. Okay, so it is simple. So that simplicity allows it to be carried out anywhere, basically anywhere. Behind a store, a supermarket, in a, in uh, in any rooms. Okay, so no special place, meaning that it is more difficult to control the environment. So higher food safety risks. Okay. Okay, so that is the end of our discussion regarding chilling. Okay, regarding chilling. So any questions? Okay, so if there are no questions, then we proceed with our next topic, that is freezing. Okay, so freezing, I have uploaded it into UKM Folio. Okay. Okay, so freezing. Okay, let's take a 5 minutes break if any of you want to go to the restroom or anything. Okay, so we'll continue at, we still have about half an hour. Okay, so around 12:40, then we can finish it up. Around 20 minutes, we'll just go a little bit on the introduction to freezing, and then we'll continue next week. Oh yeah, and I'm very sorry, okay, because I have to cancel last week's lecture because I have to undergo a medical checkup. Okay, so sorry about that. So I am suggesting, okay, if all of you are agreeable, to have additional classes next week, same time. Okay, so if any of you couldn't attend, okay, as usual, I will put a recording on YouTube so you can watch it later. Okay. Okay.
Okay, doctor.
Okay.
Okay, doctor.
Okay. Okay. Thank you. Good. So let's take a 5 minutes break, and then we'll be back at 12:40. Okay. Okay, so let's continue.
Doctor,
Yes.
mind if I ask, after our class on mid-sem break, are we having the quiz the week after?
Yes, next week.
Also, I mean, next week is our class and also quiz, is it?
Yes, correct. Okay. So what I will do is for next week, we will have class, and then 15 minutes after before the class ends, you will have your quiz. It will be an open book quiz, and then after that you you need to email your answer to me. Okay.
Okay, Doctor.
Okay.
Also, for mid-sem exam, are we having mid-sem exam after that too?
Mid-sem exam, I'm still discussing with Dr. Fatima. My intention is, my plan is for you to have your mid-sem exam 2 weeks after your mid-semester break.
Okay, Doctor.
So I will put it. Do all of you have like WhatsApp group or anything?
Not specifically for this subject.
Okay. Okay. Anyhow, I will put it in UKM folio. Okay. Because we need to find a time to have your mid-sem exam. I'm thinking of having it at night around 8 p.m.
Okay, Doctor.
Okay.
Okay, thank you, Doctor.
Okay. Welcome. Okay. Any other questions? Okay. So let's continue for about 15 minutes. Okay. So as you all have already know by now, okay, that okay, apart from chilling, okay, how do we preserve foods using low temperature? Another option or method is by freezing. Okay, so what is the difference? Both are low temperature preservation methods, but freezing, okay, it is the process of lowering temperature below freezing point of water. Okay, so the key word phrase is below freezing point of water. Okay, so low temperature process, it is a low temperature process with the formation of ice. Okay, so when we reduce the temperature below the freezing point of water, so then there will be a phase change from liquid to solid. Okay, for the water. Okay, chilling, no change, no phase change. Okay, tidak ada perubahan fasa. Okay, so no phase change, but freezing, it involves phase change, okay, from liquid to solid. Okay, so that is an advantage where, as we have discussed, okay, for chilling, the shelf life is from 10 days to a maximum of 14 days, or maybe a little bit further. Usually that is the shelf life of chilled products. Okay, however, for frozen products, the shelf life is from several months, okay, to even several years. Okay, so for example, if you were to look at this is just an example. Okay, fruits, raspberries or strawberries, raw, okay, at -12, it is 5 months, -18, 24 months, okay, that is 2 years. And at -24, it is more than 24 months, okay, more than 2 years. Okay, vegetables, okay, asparagus, for example, okay, 3 months, and then at -18, it is 12 months, 1 year, and then more than 2 years if it is stored at -24 degrees C. Okay, meat and poultry products, okay, beef, ground beef, for example, it is at 6 months, and then 10 months at -80 degrees C, and then 15 months at -24 degrees C. Okay, so personally, I have eaten murtabak that has been frozen for 1 year, and it still tastes the same. Okay, so that is the advantage of freezing as compared to chilled. Okay. Okay. However, the product needs to be thawed, okay, before use. So it is not ready to use or not ready to eat. RTUs means ready to use. RTEs means ready to eat products. Okay, they are none of either of those. Okay, so it is more tedious where you have to take it out, thaw it, and then wait for some time, and then only you can use it. Okay, and used for preserving raw and also ready-made foods. Okay. Okay, so let's look at the freezing process. Okay, where while the chilling process is very straightforward, more simple, where you just lower the temperature, no phase change, still water is still in the liquid form, but for freezing it is a little bit more complex. Okay, so involves the input of work. Work means that because not working is work, energy, work. Okay, so meaning that there is a cost to it. Okay, because we are not like quite extremely reducing the temperature below the freezing point of water. So that is requires a lot of removal of heat. So it is quite costly. Okay, that is a cost to it. Okay, so what happens is the product will experience a temperature drop at atmospheric pressure, meaning that there is no change in pressure. Okay, it is still at atmospheric pressure, but only the temperature is reduced. Okay. Okay, as you all know, at the freezing point of water, then water freezes. It will undergo a phase change from from liquid gradually to solid. Okay, and it will produce ice crystals. Okay, freezing of water produces ice crystals. Okay, these ice crystals is the solid form of water. Okay, however, not all water will freeze. Okay, not all water will freeze because it is the phase change is through a gradual process. Okay, initially there will be more liquid than solid, and eventually there will be more solid than liquid. That is when we say that it is frozen. Okay, but because in foods, okay, there are if it is pure water, then it is possible for all the water to freeze. Okay, but in food systems, because there are other aspects, other solutes that are involved. Okay, so not theoretically, some opinion of scientists is that not all water can be frozen. Okay, so there will always be a small portion of water that cannot be frozen. Okay, why? We'll discuss later. Okay, let's look at the properties of ice. Okay, because in freezing, then the water will be in a solid form that is in ice. We call it as ice. So this is one of the anomaly properties of water. Okay, because when it freezes, the properties changes. Okay, from water. Okay, so ice differs in some properties from compared to water, where water, when it is frozen, okay, it will expand. Okay, other compounds, okay, it stays, the majority of compounds will stay the same. But for water, when it is frozen, it will expand, meaning that the volume will increase. However, the mass is still the same. Okay, isi padu bertambah, jisim sama. So what happens is that the density is reduced. Okay, the density is reduced, where density is mass over volume. So the same amount of mass for water, but when it freezes, the volume increases. So what happens is the density reduces, and that is why ice floats, okay, because it is less dense than water. So this is one of the anomalies. Okay, and water expands when frozen. Okay, this is also important, okay, because in certain situations, for example, if you were to take a bottle of water, then you freeze it, then it will break the container, okay, because water expands when it is frozen. Okay, so let's take a look at the temperature profile for during freezing. Okay. Okay, so for example, this is time over here. Okay, this is time, and this is the temperature. So this is we have a product. We have water, basically, pure water, and then we will lower the temperature, meaning that we are going to freeze it, and then we want to look at what happens to the temperature over time during the process of freezing. Okay, so when we reduce, okay, when we reduce the temperature, so temperature of water will also will decrease. So it will decrease, okay, and then at this point it will stop decreasing. Okay, when we further reduce the enthalpy or the heat, okay, so what will happen is that the temperature will start to increase even though we are reducing the enthalpy. So it will start to decrease, and then it will plateau or level off, become constant. Okay, and then still when we further reduce the enthalpy or the heat, then after some time it will start to further decrease. Okay, it will start to further decrease. This depression is what we call as a supercooling. Okay, it is a supercooling. Okay, and this is where the phase transition occurs. Okay, and then over here it is liquid. Over here it is a mix of liquid and solid. Over here you have solid. Okay, so where is the freezing point? Okay, the freezing point is not here. Okay, but it is here when it is at the leveling off period over here. So this is the freezing point. Okay. Okay. During freezing, there are several phenomena. Okay, several phenomena during freezing process that we need to understand so that we know what is happening when we preserve our products using freezing. Okay, a freezing point depression. Okay, so pure water freezes at 0 degrees C or 32 degrees Fahrenheit. Okay, but when we add soluble material, sugar, anything that can be soluble in water, sugar, salt, anything, okay, then the freezing point is lowered to below 0 degrees C. Okay, below 0 degrees C. So water in food system is not pure. Okay, water in food system is not pure. This is for pure water. So, but in food system, because in food, okay, there are so many things, okay, salts, glucose, sucrose, fructose, all of those solutes, okay, soluble in water. Okay, so it is not in pure form. Okay, so what happens is that the freezing point will be depressed. Depressed meaning that it will be reduced. As opposed to freezing at 0 degrees C, now it will freeze lower than 0 degrees C. Okay, it will freeze lower than 0 degrees C. So that's what we refer to as a freezing point depression. Okay, and then there is also another phenomenon, okay, that is we call as a freeze concentration. Okay, freeze concentration. Okay, when we lower the temperature, okay, water will change from a liquid phase to a solid phase. But what will be changing? Okay, it will form ice crystals. But ice crystals, when they are formed, they are pure. They will only involve water molecules. Okay, so what happens is that in a food system, okay, now when ice forms, then actually, okay, the amount of water that is in liquid form will be reduced over time. However, the amount of solutes is still the same. So now the same amount of solute is solubilized inside a lesser amount of solvent, that is water. So resulting in an increase in the concentration of the solutes.
Doctor,
Hmm.
mind explaining again?
For freeze concentration?
Yes.
Okay. So for freeze concentration, okay, when we freeze the food, okay, in food, the water, okay, has solutes in it, okay, salts or sugars, anything, okay, has solutes in it. But when we lower the temperature, the water will form ice crystals. And when water form ice crystals, it is being formed between water molecules only. It does not include the solutes. Okay. So for example, if we have 1 liter of water, okay, inside a food system, okay, and then we have okay, for example, we have 1 liter, okay, 1 liter of water, okay, and we also have, okay, 10 grams of salt, for example, that is dissolved inside that particular food. Okay, this is before, okay, before freezing. When we freezes, okay, now some of the water has been converted into ice, into solid. So what is left may be, for example, only 900 mils of water. But, okay, but the amount of salt is still 10 grams. So now, initially, we have 10 grams of salt in 1 liter of water. Now, we still have 10 grams of salt, but now only in 900 mils of water. Meaning that for this one, for the second one, the concentration of salt has increased. Okay? Okay, so this is what we call as freeze concentration. Okay, so after freezing, okay, then the concentration of solids will increase. And actually, this is one of the method of food concentration. Okay, because when we extract something, okay, and then we want to increase it, make it more concentrated, we need to discard some of the water so that it will be more concentrated. So the common method of discarding water is just to supply heat, okay, and then the water will evaporate, right? But for certain compounds, they are very heat sensitive. So we cannot supply heat in order to evaporate away the water. So what we do is to use freeze concentration, where we discard the water, but not by supplying heat, but by reducing the temperature, allowing the water to form ice, and then discarding the ice. Okay? Okay, so quantity of solid does not change. So the concentration of solid increases. We call it as freeze concentration. So the higher the concentration affects the temperature profile during freezing. And we also know that when there is a higher concentration of solid, then the lower the freezing point depression. Right, okay, so now, okay, moisture, the temperature profile, okay, the freezing profile of water in food now is like this. It is not straightforward like this. This is for pure water. But water in food, okay, it is like this. Okay. Why is it like this? Okay, see. Remember over here. Okay, just 1 or 2 minutes more. Okay. Okay. The freezing point is this one, not this over here. Okay. So this is the freezing point. So what happened is that we have water. We reduce the temperature over time. So when we reduce the temperature, okay, the temperature of water also will decrease, and then it will experience a supercooling effect. Okay, it increases again, and this is supposed to be the freezing point of water, right? But because over here, when water becomes converts into ice, okay, so the freezing point will experience a depression. So the longer the time, the higher the concentration of solutes, the lower the freezing point depression. So then it will end up like this, in a curve. See, okay. So this is the percentage of water that has been converted into ice. Okay, so the more the conversion of water into ice, the higher, the lower the freezing point depression. So the lower the freezing point, like that. Okay. Okay. Any questions? No? Okay. So if no, then we'll stop here. Okay. For this week, and then we'll meet again, same time, same day. Okay. Next week. Okay. So thank you. See you next week, inshallah.
Thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
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 Thank you, Doctor.